Now, the double replacement is easy in terms of changing partners when you write out a reaction, but it's not so easy to figure out if it's occurred, if there's a reason why it should happen. So the first thing you can do is with double replacement is just do a metal to metal switch, or the first part of the compound switch. So if I were to take something like, let's take sodium chloride, and let's add it with silver nitrate. We want to know, will that reaction occur? Well, the first thing you have to do before you can, is the double replacement, is take the two metals here. Okay, these are the two that are going to switch. The metal's going to switch with the metal. It's two dance partners, and the guys switch dates, or the gals switch dates. And so what we're going to do is we're going to take that out, and we're going to make new partners. So Ag and Cl are going to make a partnership, and Na and NO3 are going to make a partnership. So NaNO3 and AgCl. So don't even worry about whether it occurs or not. Just switch the partners. And then the next thing is to balance them all. That's plus 1, minus 1, plus 1, minus 1, plus 1, minus 1. So they're all happy. Okay? It's all balanced, left and right side. So the big thing, though, is in this thing that you just formed here, these are the products that you formed. Did I form one of these three things? A gas, water, or precipitate? Well, is any one of these three things HOH? No. You didn't have an OH or an H as a front part to remix to make it. So they're not, these things were dissolved in water, and these things we're trying to figure out, will they stay dissolved, or will one bubble out, or will one fall as a precipitate out? So I look at NaNO3. Okay, I didn't form water. Did I form a gas? Well, those are going to be things you're going to just have to recognize. You've already seen the normal gases, H2, N2, O2, F2, Cl2. Okay, those are there. You didn't form one of those. Usually they wouldn't be showing up in this kind of reaction anyway. But you might make HF or HCl or H2S, HCN, all of those. Notice they all have what? H, 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 H. Okay? Matter of fact, these last three don't really have H, but if you realize what you'll have produced, these are unstable compounds and they like to break apart. So H2CO3 and HOH, H2SO3 all do break apart, and you'll write them like this instead. Anytime you make those three compounds, you should get used to writing them out automatically as broken apart because they're unstable, and they like to make CO2 in water, NH4 in water, SO2 in water. So really you would recognize these last three because you would make something with H in them, and then they would break apart. You should get used to just saying, oh, yeah, I got to get used to those, memorize those, whatever, so that if they show up, I would recognize them. Notice I don't have any H's in there. So I don't have water, I don't have an H compound. So all that's left is, do I have a solid, a precipitate, something insoluble? Insoluble means it doesn't dissolve. Now these rules down here are interesting because they are set up, the solubility rules are set up in a way, here I'll lower this so that they can still see the equation. The higher in this list, the more likely it's dissolved. And notice almost all of them are plus or minus 1 charge. If you have a minus 1 or plus 1 charge, it's more likely soluble. Anything from the first row in the periodic table or the plus 1 polyatomic ion ammonia always dissolves. Oh, this one dissolves, you don't have to worry about it. Silver, though, is not quite that simple. You're always looking to see the negative, actually. Look for the negative in this list, because as I said, almost everything from the first row, if you recognize that, you're just done. But if you want to do recognize the rest, these are all about the negatives that the ion is with. So you look up nitrate. Or sorry, we're down here. So sodium nitrate, you're right, sodium's from the first row, but silver's not, so we got to look up chloride. Chloride is right here. So notice I'm just going to come down and look for these negative ions. Chloride is here, and it says, they all dissolve except for 3 of them. Silver is not. So this would cause the reaction to happen. And I'll just put a PPT, that's one way you can show it, or an arrow down, and that causes the reaction. If this forms, this causes the reaction, a precipitate. I didn't form water, I didn't form a gas. Gases usually have H in them, water has HOH. But I did form something solid and insoluble because it says they all dissolve except for those 3 which don't. These 3 do not, so it created the reaction to happen. So that's the rules for the double replacement reaction. Switch partners and then look to see if you form water, gas, or a precipitate. The precipitates are based on this. Everything down here with a -2, -3, actually this should even have a -2 on it, has usually is insoluble, except for if it's this first column in the periodic table. All right, so see if you can follow through on those rules and get the hang of that.